These are slides that I have thrown together in a lightning fashion. This is a project that was inspired by a throwaway comment about 4 years ago at GRCon, and it's been the bane of my existence ever since, because this is a really cool idea that I wish we'd gotten a lot farther on. Obviously we're not at Berkeley SETI in 2021, so ignore all of this slide. I will be talking about LiteX. This is a system-on-chip generator framework, which is open source. It's developed by Enjoy Digital, Florent in France, and it is written in Python and nMyGen, which is a Python-based hardware description language. It fully renders out to Verilog, so it is compatible with integration in many other tool chains, and it is also compatible with integrating VHDL, Verilog, and other languages within it. It is deployed out on a number of SDRs as its primary gateware. The HDL component of the FPGA is written in this, and so it is field-proven and fairly mature. LiteX, this is a very quick enumeration. Mostly we'll post up the slides and links, and so you can follow that on, but it is fairly featureful and very easy to use as somebody such as myself who is not an FPGA developer by primary role. I can take some code, I can modify it, but that's really a stretch. So if I want to dig into something like an entire system on chip with PCIe and other components, this is really a helpful tool for me. So what did I want to do with this? I wanted to connect up a bunch of basically GNU radio style blocks within an FPGA. Haha, isn't this a familiar concept? And so as a relative beginner, I wanted something that would basically plug and play this. So apologies to Florent. This image, I don't know if it's actually currently available on the internet, but I promise it has been in the past, so it's relatively public. There was a concept called Light Accelerator, or Light Compute, which builds upon LiteX and strips out the RISC-V processor and a lot of the architecture that is there. If that's of interest, go check out the ability to run LiteX processors and Linux on board FPGAs, that this tool just drops out the entire environment. But I want to be able to take samples in via PCIe, stream it through a whole bunch of blocks, and then back out the PCIe. So what does this look like in code? And my goal is just to motivate you to that. This is really cool. I have some pieces here that we can hack on tomorrow, and I can show you how this actually runs. This is the base of the system on chip, so it's a really quick declaration saying, I want to inherit all of your good work and do very little with it. Give me a PCIe interface, so the variant is just telling what hardware I'm using. I'll show you a picture of that in a moment. And give me a PCIe interface, please, with some configuration settings. And self.add PCIe, add this PCIe to the system on chip. Done. And then I have 2 blocks that I'm calling compute modules. Please instantiate those and connect them up into a pipeline. Please give me PCIe DMA straight into Compute Engine 1, then into 0, and then into 1, and then back out a DMA sync on the PCIe. I mean, look familiar and look approachable? Yes, please. So what does this compute engine actually look like? I am no DSP engineer on FPGAs, especially not on the about 3 weekends I've had to play with this. So for this, the pipeline stages are just adding 1 to each sample value that's going through. So within GNU Radio, we can do it's a constant add. But proof of concept, this streams really quite quickly, and I can get about 200 to 300 megasample per second through on this tiny little board that I'm using. So conscious that I am running out of time, the board that I'm using is this. It's a tiny little Bitcoin miner, which came available on eBay in mass supplies when these became completely obsolete. It's an RTX 7 200T FPGA, so it doesn't require a paid license of Avato. The LiteX toolchain will just do all of the FPGA build itself. It's tiny, and I have it in a little Thunderbolt enclosure. Kind of as a bit of motivation, my goal for tomorrow, if I have time to hack on things, is to integrate this tool, which generates compatible FIR filter code into this block. It should be copy and paste. We'll see how far it goes. But it's a really cool tool, and I had a student 2 years ago actually write GNU Radio blocks. So we have a PCIe source and sink that will send data to and from GNU Radio host streaming environment and DMA it out to the PCIe. So apologies for not really having a demo running, but catch me sometime and I can show you how this works. If this looks cool to you, I would love to have somebody else help out with this. I'm hoping to have a little bit more time, but that's about as far as I've gotten. There's a lot of documentation online with all of this, and I can send you a link to this compute test. Florent did the vast majority of the bulk lifting on this, and I'm really just pointing it out as something that I consider very cool. With that, I'll be around. Please ask me questions then.